In this video, we're going to talk about some more complex extended access lists. We're going to continue our discussion about access lists, extended access lists, and make them into more complex environments, something that you might see more in the real world. As an example, I have an environment here with a couple of requirements. Very briefly, we can look at the environment. We have out here the internet, and that should be pretty much untrusted. That's where all the hackers are, so we don't want those in our environment. Over here on the left-hand side, we have our DMZ, and this is where all of the servers that we want to publish out to the internet are. For instance, we have right here a DNS server, and so we want to be able to publish DNS so that all of these clients can come in here and access DNS. Same thing with, we have a couple of web servers, so we want clients to come in here and access port 80. And then lastly, we have an FTP server that all the clients should be able to come in and access over FTP. So we want to be able to publish these, but we only want to publish those specific ports. Additionally, down here at the bottom, we have what would be, say, our corporate environment or our trusted environment. In this case, it is specifically two different VLANs, so we're throwing in VLANs into our mix here. These guys should be able to access the internet without any issue. However, the internet should not be able to access it back. And what I mean is that the untrusted internet should not be able to come up to the trusted internal environment. When it comes in, it should be denied. So let's go ahead and look at our rules, or our rule needs. Very first rule: DMZ servers, desktops, DMZs servers and desktops can access resources on the internet. That's going to be a fairly simple rule. Basically, all of these guys, the DMZ should be able to go out, these servers should be able to go out, and the desktops should be able to go out. Looking at the data flow here, we can quickly identify probably one specific interface that we want to be able to put this on, and that is going to be this interface right here. And then when we that interface right there, because that's where all the traffic goes through. At the same time, when we look at that, we can then see, oh, well, this is all outbound traffic from the router's point of view, and therefore we know now which interface and which direction to apply that rule. Now, here's something that we need to worry about, though. If I'm going out to the internet, if I'm typing in on my web browser www.google.com, or web.test.com, that is the outbound traffic from my client. However, the web server then sends back a response. So we have to actually create two rules, or two sets of rules, and there's a lot of ways that we can do this. This response traffic, there's a couple of things we can do. First, we can actually set up ACLs that allow specifically, say, port 80 and 443 from the internet to come into my network. That allows the return traffic to come in. That's not ideal always, because other things can run on 80 and 443, and maybe I'm running a client that doesn't use 80 and 443. You know, there's some other business reason I need to use an application that doesn't run on standard web ports, and therefore that one access list will be an issue. Otherwise, under Cisco devices, there are a couple of other options. There is what's called an established option. What happens is when the outbound traffic goes out to the internet, the router can identify that traffic as being an established connection. So it looks at the, what it does is it looks at the traffic and it says, this client right here is sending traffic this way, and maybe this port right down here is 1051, and it is talking to port 80 on the web server, and therefore when it sees return traffic from port 80 down to port number 1051, it identifies that as being an established connection and therefore allows the return traffic to come through. That's one of the options, is to be able to identify what the established connections are and automatically permit those. The other option is to use an inspect option. Basically, it's kind of the same thing. The router inspects the traffic as it's going out and then allows the inspected traffic to come back in. And then the very last option would be NAT. We can actually NAT the outbound traffic as a single IP address and then allow the return NAT traffic to come in. If this was a normal production environment where we only had, for instance, one IP address right there, that would probably be what we would use. However, in this environment, in order to make things a little bit simpler, this entire environment is entirely routable and does not require NAT. So it actually allows us to do all of these options. There's probably more options. These are the three that are coming to mind right now. All right, so that's option number one. We can use ACLs, we can use the established keyword, we can inspect the traffic, or we can use NAT. I'm actually going to try established. Second item on our list is that we need to publish the DNS, web, FTP, and DMZ traffic. So we need to come over here to these clients right here, and we need to configure the firewall or configure the access lists to allow, for instance, DNS, F53, TCP, and UDP from the internet, web, port 80 and 443 from the internet, and then the FTP port 21 from the internet. Again, so if we look at the data flows, that is going that way. So which interface do we put that on? We could put that on either this one or this one. And then lastly, the internet cannot access servers from desktops or networks. So the internet should be able to, if we come through this way, it should not be able to succeed. These last two rules actually tie together because we have, when we're talking about internet-based traffic coming into the company, we have one destination which shouldn't succeed and then another destination that should succeed, which then we can kind of start saying, oh, we've got one interface right here that is consistent amongst both of them. So if we look through that fairly quickly, we've got a lot of rules to create. However, everything is going right on that interface right there. So let's look at it. We'll start off by creating our Excel spreadsheet. It always comes down to the spreadsheet of what we want things to look like, so that we can have everything, so we know exactly what we're going to do before we actually start working on it. So we start off with our list: permit/deny, source IP, source port, destination IP, destination port, interface, direction, and then rule name. And so we start looking at our rules. Very first one is that everything can access the internet. All right, so we need to be able to allow everybody to access the internet. So let's go ahead and we'll start off with a rule. Let's call access internet. And so what do we want to access the internet? Well, we want everything inside of our organization. And if we look inside of our organization, we have a 10.4.15.0/24, a 10.4.5.0/24, and a 192.39.101.128/28 network. So let's create those three rules for those three networks. So I'll start off with a permit. Source IP is going to be 10.4.15.0/24. Source port, any port we want to be able to access the internet. And again, the client side can be randomly selected. So I'm going to say star. Destination IP. Well, now we start asking ourselves which IPs are on the internet. Well, if we look at our diagram here, we only have a couple of IPs. But in reality, the internet has millions and billions, in fact, of IP addresses. So the destination IP really should be wildcard. We want to be able to access any IP address. Which ports do we want to access on the internet? We can be a little restrictive here. We could actually say we only want 80 and 443. However, we then start talking about applications that run on ports other than 80 and 443, and suddenly our super secure environment becomes a nightmare that we have to maintain because we're adding in more and more ports. Instead, for this very simple example, I'm just going to say any. Which interface? I'm not actually sure what that interface name is, so I'm just going to say R0 internet. And then the direction is going to be outbound, because we already said that it's going to be outbound traffic. So that was one network. What we're going to do essentially is we're going to copy that line 3 times because we have 3 different networks. So there was 10.4.15, the other one was 10.4.5. And then lastly, 192.101.128/28. So that is our rules for allowing access for the internet. That's line number 1 here to the internet. We still have a question of them coming back, but we have other things coming back from the internet as well. Remember, we have back returning traffic for our clients, as well as we have in lines number 2 and 3, we have traffic coming into our DMZ and traffic not coming into our corporate environment. Therefore, we have a second direction or second flow of traffic coming into the company. So our return traffic from our internet access is going to be in a second rule. Hopefully that makes sense. We'll start off with the second half of this right now. So what we're going to do, we're going to start off with another rule. This time I'm going to call it publish internet. Sure. And I'm going to start off with one specific rule. It's called permit. And instead of a source or a destination, I'm going to say established. A source port, destination port is going to be NA. There is no destination IP, and then destination port will be that. So what this is going to do is this is going to say if there is any established traffic coming in to the router, go ahead and permit it. Which interface do I put that on? Well, that's the outside interface, so it's the exact same one that we already did right here for the outbound traffic. The only difference is the direction is going to be in. So R0 internet and inbound for that. Again, very briefly, what that means, one last time. If I have a client on the 10.4.15.0 network, so this guy right here is going out through the internet to a web server. This establishes a connection. Establish. And it says, okay, I'm communicating with this web server. When the web server talks back, the router looks at it and says, yes, this is an established connection, so I will permit it back to the client. Piece of cake. So that should be our return traffic from the internet. We still need to publish our DNS, web, and FTP. So from the internet's point of view, again, we are now permitting. In this case, we're coming from the internet. Which IPs are on the internet? Pretty much everything is on the internet. So star. What source ports are on the internet? Again, the source ports for most communications are randomly identified or randomly generated. So the source port is going to be a wildcard. And now the destination, comes down to what our server IPs are. I believe, correct me if I'm wrong, I believe the DNS server is 192.168.101.129. Yes, 130. Actually, I have the actual configuration up and running right here. Let's see. The DNS server is .130. Awesome. Okay. So 192.139.101.130, and then the destination port DNS is 53 UDP, and then this is still publishing to the internet, so that is still R0 internet. It is inbound, and it is the publish internet rule. Because DNS can run both UDP and TCP, I'm going to copy and paste this line and then change that to TCP for the second copy. All right, so that was that was the DNS. Let's check out the web servers. This guy is .131. The second one is 133. So that means I need 192.139.101.131 and 192.139.101.133. What I was doing there is I was just pre-filling the answers because now we need to publish the web server. The web server is going to look exactly like DNS, just a different port. So permit. Who are we permitting? We are permitting anybody from the internet using any source port to talk to our web server, our first web server. The web server port is port 80. I could include 443 in here as well. This is just an example, so I'll just say 80. It's still coming in from the internet exactly the same as the DNS was. It's inbound, and it's going to be on the rule called publish internet. Same thing for web server number 2. It is exactly the same, just a different IP address, same port, and same rule name. And then very last is the FTP. Well, that's going to look exactly the same. We just need to find the IP address of the FTP server, which is 132. So permit everybody from every port to access 192.39.101.132 on port 21, R0 in, and publish internet. Okay, so we've gone ahead, we've created server rule number 1, or our first rule for this guy, to allow everybody to be able to access the internet, to browse the internet. We have then started with rule requirement number 2. We have published our web servers and our FTP servers out to the internet so that people from the internet can access those. And then requirement number 3, nobody should be able to access anything inside the company. We've actually already done that as well. We didn't specify it, but we have already done that because down at the very bottom, there is an implicit deny at the very end of our publish internet rule, as well as the access internet rule. Because we are not creating a permit rule for people from the internet to access our servers or our desktops, we are implicitly denying them from accessing them, everything else, or accessing those networks. So that should be, cross our fingers, everything we need for our 3 requirements there. Well, let's check it out. So I've got our network right here. Currently, everything is already configured. So if I fire up this DNS server, I should be able to ping 13.35.99.23. I'm pinging our web server out there, web.test.com. That worked. I can also ping, let's see, from the internet, I should be able to ping this guy. Should be able to ping our, what is this guy? 10.4.5.10. So as you can see right now, everything has been IP'd and routing is working. There are no access lists at all blocking any traffic. So everybody from the internet can access everything internally. Everybody internally can access everything from the internet. It is the Wild West. Nobody is stopping anything. So what we need to do now is we need to create our access lists on our router. And this is going to be a piece of cake because we've already created our firewall rules. We've already defined what our permits and our denies are. Now it's just a matter of typing them out. So put that down there, move this up here. So we go ahead into configuration mode. And I will go ahead and start with a rule that allows everybody to access the internet. So I'll create this access internet rule. So IP access list, it's going to be an extended access list, and I will call it access internet. Very first line, permit. We want to allow, let's see, permit question mark. Asks us which protocol we want. We want IP because we want both TCP, UDP, OSPF, ICMP. We want all of these protocols to go through, and they're all part of the IP protocol suite. So permit IP. Which source IP do we want? We want the 10.4.15.0. And then what is our wildcard? Remember, the wildcard is the opposite of our subnet mask. So it's going to be 0.0.0.255. Question mark. Our destination address, in this case, it's going to be any. And really, that's it. That is our first rule there. We don't need to specify any ports because it's IP as opposed to TCP. Our first access rule is done. Second access rule is exactly the same thing, except it is 10.4.5 instead of 10.4.15. I'm just going to up arrow on my keyboard and then change the 15 to a 5. Second rule is done. Third rule is essentially the same thing. So I'm going to, actually I'm not going to up arrow that because, ooh. Let me get back into that. IP access list extended. There we go. So permit, I didn't want to up arrow it because I realized I have a funky mask right here. I have a /28. So permit IP 192.39.101.128. And now what is my funky looking mask? And for that, I'm actually going to cheat. I'm going to do a subnet calculator. Subnet calculator. And we are talking, let's see, 192. Yeah, this is a class C. 192.39.101.128. And that is a /28. And because I cheated, I'm able to see very quickly that this is a 00015 wildcard mask. 0.0.0.15, and the destination is any. There we go. My first access list is done. My first access list called Access Internet is complete. Halfway there. So we've gone ahead, we've done this guy. Now we need to do the other one. All right. So IP access list extended. Let's call this one publish internet. Start off with the very first one, permit. Let's see, permit IP. We want any type of traffic. Where is established? No, permit TCP, excuse me. Any There we go. And now we get our established keyword. So any TCP traffic from any source to any destination, if it is established, it will be permitted through. Research the differences between established and inspect and natting. There's very good reasons to be able to use the different ones, different types. So that's our established keyword. After that, we are now publishing our DNS servers. So permit UDP. Again, our source address is the internet, so any destination address 192. Excuse me, it's not just 192, it is host, because we are publishing a single host out to the internet. So host 192.39.101.130 question mark, and then says equal to a given port number. So EQ question mark, and domain is actually one of the items on the list here, so we can just go ahead and type in domain. So that permits UDP port 53, and then I should be able to just simply up arrow and change UDP to TCP. So that's both UDP 53 and now TCP 53. Great. So now I just need to publish the websites and the and the FTP server. So permit TCP any host 192.39.101.131 equal to, in this case, I want World Wide Web. So just going to type www. That was the first web server. The second web server is the exact same configuration, just a different IP address. So I'm just going to up arrow on my keyboard again, change 131. And then lastly is the the FTP server. Again, it's the exact same configuration, just a different IP address and a different port. So I'm going to up arrow. I'm going to change both of those. IP address is 132, and then the port is FTP. And enter. Okay, our rules are created. Now all we need to do is apply those to our interfaces and in the correct directions. Let's see. So the interface we want to assign this to is going to be 54.239.172.237. So do show run. That should be serial 010. So I'm going to go on to serial 010 and apply those two access groups in the correct directions. Int serial 0/1/0 IP access group access internet, and the direction for going to the internet was actually out, because remember, it is the clients here. It is these guys right here going out. So it's outbound. And then the other way around was coming back in. So IP access group publish internet. Hopefully I'm typing these in, and that is in. Sorry. Hopefully I'm typing them in correctly without any typos, without any case sensitivity issues. In fact, I'm going to do a show run just to confirm. Publish internet, access internet, access internet, publish internet. Those look like the same. We will see if that is the case. So very quickly, let's find out. Our desktop should be able to browse to the web server 13.35.99.23. Yay, web.test.com came up. However, if I come back here to my test client out on the internet, previously I pinged PC0. If I up arrow and hit enter, it should fail. Destination host unreachable. Great, firewall blocked it. It said you can't talk there. So we're blocking the internet from coming into our company. Yay! However, this client should be able to access the two web servers. 192.101.131, I believe was one of them. I typed in the wrong IP address. 192.139.101. There we go. That's server web 2. The other one was 33, and that is server web 1. So our two web servers are working. Hooray! And then the FTP site. If I come down here, FTP 192.39.101.132, and I can connect to the FTP server. Just to be certain, these web servers over here are also running the FTP service. So I'm going to try to FTP to those, which should fail. That means our firewall is working right. That means our access lists are blocking FTP requests to that server. Same thing, the FTP server is also running a website. So if I come to the web browser, 192.39.101.132, it should time out because the access lists are blocking the rules. So there we go. We've gone ahead and we've created a ton of access lists, and it seemed hard at first. How would you actually set all these up? That becomes a fairly complex environment. As we start looking at the data flows, as we start looking to see how traffic goes from the desktops to the internet, from the servers to the internet, and then the DMZ to the internet, and then how the internet talks back with established or inspected traffic, as well as how we publish to specific websites. It actually becomes fairly simple when we start seeing the flows that right here is where all of the data seems to be going through. So then we can start bottlenecking and inspecting all of our traffic in that one spot. Are there other ways to do this? Absolutely. There are a million different ways to do it. This is the way that first came to me. I would be very happy to see how everybody else does it.